Uh, on the screen, please check the questions. Question number 1, weight in kg is what kind of variable? So question number 1 and 2, they are linked to each other. So solve both 1 and 2. Identify what kind of data is that? What kind of variable are we talking about? Please solve even second question also. Okay. Now I'm very happy that you were able to identify it. The weight is always a continuous variable. The other continuous variable examples are blood pressure, blood sugar level, height, age, very commonly asked as MCQs. All these are okay. Temperature, okay, again very commonly used. Now gender, it's an example of qualitative data. Now in my lecture notes, I would have given you, if I have not given you there, understand this concept very clearly. Now, in the previous class of epidemiology, I did tell you about the scales of measurement in epidemiology, nominal, ordinal, interval, ratio. Okay, so interval scale. So if the data is on interval scale or ratio scale, okay, you will go for a continuous variable. Okay, always remember this. Now if the data is nominal or ordinal, mild, moderate, severe, good, fair, poor, ordinal data, okay, angles classification, all these are examples of nominal and ordinal data, you will go for uh, qualitative data. It will help you, as you know that based on how you identify the data, the test of this thing significance will be applied, whether you will go for T or chi-square or ANOVA. Okay. So question number 3, 4, and 5. Next is 3, 4, and 5. What is discrete? Discrete is nothing but qualitative. Dr. Parul, already been given to you. Discrete is nothing but qualitative. Follow the same thing, it will be easy for you to understand. Don't try to read from Pulse or Schumpeter. It is slightly confusing for the student there. So two variables can be plotted and compared together. What have you marked for 3? It is scatter diagram. Yeah, also called as dot diagram, also called as a correlation diagram. That means you are correlating two variables. Okay, correlation diagram. Okay, you are correlating two different variables. A frequency polygon showing the trend of an event occurring over a period of time, rise or a fall. All of you have marked line graph. Yeah, correct. Line graph is the answer for it. Okay. Now, if you look at question number 5 and 6, which some of you have already started marking for 5, what is the best method to show association between carries and age? There are two variables here, carries and age. Now, generally, when you're plotting a graph, scatter diagram is the only one where in both x-axis and y-axis you will have the variable. Okay, generally the variable will only be on the x-axis and y-axis will have the frequency, but it is this only diagram where you have both. Okay, so the correct answers are dot diagram, because it is there are two variables, variable 1, variable 2. Okay, and which is used to depict fluorosis belt. It's map diagram, also called as cartogram, which again I'm sure that you are aware of. Geographical distribution, any geographical distribution that you would like to show, it has to be in the form of you have to show it with respect to map diagram or cartogram. It can be local variation, it can be national variation, it can be rural urban variation, or anything. Okay. Now question number 7. If children, I think my photo is blocking it. I will just come and make it easier for you. Okay. Yeah. If children of India at 4 years form 20th percentile, it means 20% of the entire population is above, below, or equal to 4 years. So you already have started marking it. Yeah. So, question number 7, the answer is below 4 years. And when you arrange the values in ascending or descending order, you generally use median, the centralmost value. Okay. Question number 9. Okay. Question number 9. The most commonly used method for central tendency when you have a skewed distribution. Okay, you will use which, mean or median or mode. I have told you this also in the class. And question number 10, the most commonly used measure of central tendency among the following is which one? Please mark 10 also. Okay. Since all of you are marking it correctly, I am very happy. The first one has to be skewed distribution, has to be median, and mean will be the most commonly used measure of central tendency. Question number 11 and 12. Question number 11 and 12. Uh, the incidence of malaria in an area is 200, 250, 500, 5,000. Look, you don't have to calculate. Okay? You don't have to actually. There is a reason behind why this question is asked very simply, because now there is an extreme lower value and there's an extreme higher value. So you have extreme values. Your mean is going to be not going to give you a correct interpretation. You will have to go for median only. Okay, it is positive, not what do you say? Negatively skewed. Sorry, positively skewed. Mean is going to be bigger than median. Okay, so in this case, mean and median are not equal. So mean is going to be bigger than median. Hence, this kind of data is positively skewed. We have done this during normal distribution curve. So question number 12, a measure of location which divides the distribution in the ratio of 3:1, which I'm sure you already have marked it. Yeah, third quartile is the correct answer. Very good. Okay, third quartile is correct. Okay, so question number 13 and 14. Question number 13 and 14. All of the following measures are same except, okay, and if the 10 babies are born on the same day, all weigh 2.4 kg each. Calculate the standard deviation. Calculate the standard deviation. Yeah, if you have finished marking 13 and 14. So I'm so happy that all of you have marked correctly. This is D, second tertile. Tertile means 33%. 33% twice. That means it will become 66. Whereas three, the remaining three, they are all dividing the distribution exactly at 50%. When the 10 babies are born on same day and all of them weigh 2.4 kgs, the SD will be 0. The SD will be 0. Okay. We're very happy that you all are answering so confidently. Question number 15. All are uses of SD except indicates that the variation of difference is between from a chance or real. helps in identifying standard error, helps in finding suitable sample size to compare variability of one character with other character. Question number 16, for comparison of two different series, which is the best measure? 16 also, can you please solve? 16 also. For comparison of two different series, which will be the best measure of dispersion? Please mark for 16 also. Okay, 15 and 16. Don't worry if you're wrong. You just mark. Okay. Okay. Now, some of you believe that it is standard deviation. Some of you believe it is coefficient of variation. Okay. Now, always remember that when you are comparing two different series, the best measure will be coefficient of variation. The formula is SD divided by mean into 100. We generally don't use statistically coefficient of variation. I am aware of it. Okay, I am aware of it. But all I'm saying is, when you're measuring two, for if you remember the example also I've given you, to find out the variation of height among adults or child. So there are two different sample groups here. Okay, so then you can also, for example, to find out variation of blood pressure among diabetes among pregnant women and non-pregnant women, like that. So there are two different series. When you have CV is a much better indicator. Okay, you use generally CV. Now coming to question number 15, which I'm very happy that all of you have marked correctly. This is what is the application of coefficient of variation, CV. Okay, this is what is the application of coefficient of variation. Now question number 17 and 18. Question number 17 and 18. In a population of pregnant women or females, hemoglobin is estimated in 100 women with a SD of 1 gram percentage. What will be the standard error? It's very straightforward. 18 also, please mark what is true about, what is false about normal distribution curve. That means there are three statements which are truth and one is a false statement. So please mark both 17 as well as 18. 17th, you have to use the formula standard error is equal to standard deviation divided by under square root of n, which is 100. So SD is 1, sorry. SD is 1 divided by square root of 100. It will become 0.1. Okay, so that is your answer. B is the answer, and I'm very happy. Mean of the curve in a normal standard normal curve is taken as 0. Okay, not 1. SD is taken as 1. Uh, Coming to 19 and 20, which shouldn't be a problem for you. Please mark for 19 and 20. If the null hypothesis is false, but you're still accepting it, then what are you committing? And if the null hypothesis is true, but still rejected, then what are you committing? Okay, I'm really happy that you are all marking correctly. Uh, this is type 2 error. Okay, and this is type 1 error. So if in case some of you are not aware of it, normal distribution curve is there. This is the 95% confidence interval. Okay, so what we do is we will change the thing and you increase the confidence level and the value falls here. If the value falls here, generally what you do is you will reject the null hypothesis. You will say false, but now what you're doing is you are accepting it. This is type 2. The reverse is your type 1 error, wherein you are decreasing the confidence interval, okay, which if the value falls usually here, let us say this green, you should have actually accepted the null hypothesis, but now what you're doing is you're rejecting it. Hence the green one is type 1 error and the red one is type 2 error. Okay, question number 21, 22, 21 and 22, the type of sampling which is used in schools, factories, hospital is what? A type of sampling in which part of the information is obtained from the whole sample and part from the subsample is which one?